Hello students, here is a problem related to Lagrange's method. So we have seen up to now so many problems. So here is another model. So using Lagrange's method, derive the equation of motion for a 2 degree of robot arm. The center of mass for each link is at the center of link. So the mass is concentrating at the center of the link. So the moment of inertia is given as I1 and I2. So you have to derive an equation for this using Lagrange's method. So the solution for this problem of robot arm is in fact similar to the solution of the previous problems that we have done using uniformly distributed mass. So however, in addition to that, there is a change in the coordinate of frames, as well as the two links have distributed the mass. So the mass is distributed in the two links, requiring the use of moment of inertia in the calculation of kinetic energy. While you are calculating the kinetic energy in the previous problems, we don't use the concept of inertia, but in this as the links are distributing the masses, so we have to use the concept of inertia here. So in order to calculate the kinetic energy, so we will be following some few steps that we have done already in the previous problems. So here is the first thing that we have to do is we have to find the coordinates with respect to the point D here. So you can see the two links. So one link is L1 and link length of link 2 will be the L2, and moment of inertia I1 and I2. So we'll be having the angle theta 1 and theta 2. So we'll be having that. So later we'll be calculating the coordinates with respect to point D here. So we'll be having with respect to x-axis, we'll be having as L1 cos theta 1 with respect to x-axis. So with respect to x-axis, we'll be having L1 cos theta 1 plus we'll be getting as half of L2 cos theta 2, that is 0.5 L2 cos theta 1 plus theta 2. Okay, so we'll be writing as cos 1 2 here in place of cos theta 1 plus theta 2. Okay, so that it will find somewhat difficult, somewhat easy while you are writing the equation. Okay, so after that, we with respect to y coordinate, we will be getting as L1 sin theta 1 plus 0.5 L2 sin theta 1 plus theta 2. Okay, so after going for time derivative of these two things, so if you go for the time derivative, we will be getting the velocity equation, that is x dot d. Okay, so you will be getting an answer of minus L1 sin theta 1 theta dot 1 minus 0.5 L2 sin theta 1 plus theta 2 into theta dot 1 plus theta dot 2. Okay, so this is the time derivative of this one. Okay, so we got it as minus L1 sin theta 1 plus 0.5 L2 sin. So we'll be getting a time derivative of cos as sin theta 1 plus theta 2 into theta dot 1 plus theta dot 2. Okay, so similar to that, we'll be getting the time derivative of y coordinate, we'll be getting as L1 cos theta 1 theta dot 1 plus 0.5 L2 cos theta 1 plus theta 2 theta dot 1 plus theta dot 2. Okay, so this is the coordinates of x and y and time derivatives of x and y. Okay, so therefore the total velocity of the center of mass link 2. Okay, so the total velocity of center of mass link 2 will be getting as velocity d square is equal to x dot d square plus y dot d. So we'll be doing the modulus square. Okay, so we'll be going for velocity square. So we'll be getting an answer of theta dot square into L1 square plus 0.25 L2 square plus L1 L2 cos theta 1 dot cos theta 2 theta dot 2 square plus 0.25 L2 square plus theta dot 1 into theta dot 2 into 0.5 L2 square plus L1 L2 cos 2. Okay, so this is the modulus square of total velocity of center of mass of link 2. Okay, so we just done the modulus square. Okay, so velocity square, so the total energy for the system is the sum of the kinetic energies of link 1 and link 2. So we have to do the kinetic energy K is equal to K1 plus K2. Okay, so we have to go for calculation of kinetic energy, that is K1 and K2. So remembering the kinetic energy of link rotating about a fixed point of for the link 1 and about the center of mass for the link 2 is that is given below, that is that we have given here. So we will be having as K1 plus K2. So we will be getting as I already told you. So as the mass is distributed here, we are going to take the help of inertia. So K1 and K2, so we'll be taking as in order to calculate the inertia here, so in order to calculate the kinetic energy here, so K1 is equal to, so we'll be taking as half inertia into theta dot square. So that will gives you the kinetic energy here. So that is the value here. So inertia is nothing but, so if you take some small area here from center, so we'll be having some small area which is having a length of dl. So inertia is nothing but density into length into total distance. Okay, so inertia is equal to density rho into dl, the small length into total length, that is the total length is L1 square, distance square. So that is the element of mass. So we'll be getting, so in order to get the total inertia, so we'll be going for integration. So that is 0 to L1. So we'll be going for 0 to L1. So we will be, after integration we will be getting a value of so if you integrate that, so we'll be getting an like this, so rho into L cube by 3, that is 0 to L1. Okay, so we'll be getting as m into L square by 3. Okay, so that is the for first link. So if we go for second link, so we'll be getting as so as here we are having two motions. Okay, so with respect to the mass is moving with respect, so the link is moving with respect to mass. So suppose here we are having link like this, right? So it is moving the mass from here to here. Okay, from here to here with respect to mass, as well as it is having a linear motion. Okay, so here two motions are there. So that's why we will be taking as half into I into angular velocity, inertia into angular velocity, plus half into mass into, that is linear velocity. So we'll be taking the linear velocity m2 v2 square. Okay, so we'll be taking the inertia as well as so we'll be getting as half into I into theta 1 dot plus theta 2 dot square plus half into m2 v2 square. So we will be getting as, so after similar to the first link, so first link la chesamo similar to that, so we will be taking a small part which is at a distance of some distance square. So we will be getting a value of 1 by 12 of m2 l2 square. Okay, so we'll be getting like this. Okay, so after substituting those values, so we'll be getting as, so k is equal to 1 by 2 into 1 by 3 m1 l1 square into theta dot square plus 1 by 2 1 by 12 of m2 l2 square into theta dot 1 plus theta dot 2 square plus half of m2 velocity square. So vd dot vd square. Okay, so we have already got the vd square. Okay, so vd square we have got here, so we'll be substituting this value in equation 2. So in this equation 2, okay, so after substituting that, so we'll be getting as theta dot square into 1 by 6 m1 l1 square plus 1 by 6 m2 l2 square plus 1 by 2 m2 l1 square plus 1 by 2 m2 l1 l2 cos 2 plus theta 2 dot square into 1 by 6 m2 l2 square plus theta 2 dot into 1 by 3 m2 l2 square plus 1 by 2 m2 l1 l2 cos 2. So we just substituted the vd square here, so we will be getting the value of kinetic energy like this. So after that, so we will be substituting the value of potential energy, that is potential energy is nothing but mgh. So mgh, so mass into gravity into height for the first link. So the mass is concentrated here, that's why we'll be taking as L1, so total length by 2, and as well as the height will be sine theta 1. Okay, so next we'll be taking as mg m2 gravity 2 into L1, total L1 plus sine theta 1 plus L2 by 2 sine theta 1 plus theta 2. Okay, so that is the potential energy that we are going to get it. So potential energy P is equal to m1g into L1 by 2 sine theta 1 plus m2g L1 sine theta 1 plus L2 by 2 sine theta 1 plus theta 2. Okay, so after that we will be keeping the whole thing in the Lagrangian equation. L is equal to kinetic energy minus potential energy. So we will be getting a value of theta 1 dot square. So we will be getting the equation like this: m1 l1 square plus 1 by 6 m2 l2 square plus 1 by 2 m2 l1 square plus 1 by 2 m2 l1 l2 c2 plus theta 2 dot square plus 1 by 6 m2 l2 square plus theta 1 theta 2 dot 1 by 3 m2 l2 square plus half of m2 l1 2 L1 L2 cos 2 minus m1g L1 by 2 sin m2g L1 sin theta 1 plus L2 by 2 sin theta 1 plus theta 2. Okay, just remember sin 1 means sin theta 1. Okay, sin 1 2 means sin theta 1 plus theta 2. Okay, so we have to remember that, just don't forget that. So after this, so we'll be taking the derivative of the Lagrangian equation and substituting the terms into the equation. Okay, so we have to take the equation of motion, that is torque T is equal to, so we'll be getting equations and d theta by dt by dt theta dot. So we have the equation dt by d theta dot. Okay, so మనం ఏంటంటే కనుక we have to find the derivative of that Lagrangian equation in order to find the equation of motion. సో మనం ఏంటంటే కనుక దీనికి డెరివేటివ్ ఫైండ్ అవుట్ చేయండి. సో ఎక్కడైతే టీటా డాట్ ఐ ఉందో దానికి మాత్రమే మీకు డెరివేటివ్ వస్తుంది. ఓకే, సో దాన్ని బట్టి మీరు డెరివేటివ్స్ చేయండి. ఓకే, అలాగే నెక్స్ట్ డి టీటా బై డి టీటా ఐ. ఓకే, సో ఈ రెండు కూడా మీరు సాల్వ్ చేస్తే కనుక మీకు యూ కెన్ గెట్ ద ఈక్వేషన్ ఆఫ్ మోషన్. ఓకే, సో అది కూడా నేను రాస్తాను ఈక్వేషన్ ఆఫ్ మోషన్. సో మీరు ఏం చేస్తారు అంటే కనుక జస్ట్ ట్రై టు డూ దట్ ఈక్వేషన్ ఆఫ్ మోషన్. సో మీరు కంపేర్ చేసుకుంటున్నాను. సో 1/3 m1 L1 స్క్వేర్ ప్లస్ m2 L1 స్క్వేర్ ప్లస్ 1/3 m2 L2 స్క్వేర్ ప్లస్ m2 L1 L2 cos theta 1 theta 2 into theta double dot 1 plus 1/3 m2 L2 square plus 1/2 m2 L2 సారీ ఇక్కడ L1 కూడా ఉంటుంది, L2 cos 2 into theta double dot 2 minus m2 L1 L2 sin 2 theta 1 theta 2 theta dot 1 theta dot 2 1/2 m2 L1 L2 sin 2 theta dot 2 square plus 1/2 m1 m2 to g into L1 cos 1 plus half of mg L2 cos theta 1 plus theta 2. Okay, so this is the equation if we do theta d theta by d theta dot. ఓకే, అది చేసినప్పుడు మీకు వచ్చే వాల్యూ ఇదండి. ఓకే, సో ఒకసారి మీరు ఈక్వేషన్ ఆఫ్ మోషన్ కంపేర్ చేసుకోండి, అట్ ద సేమ్ టైం రెండోది కూడా మీరు చేసి నాకు చెప్పండి నాకు. ఓకే, సో విత్ దిస్ వీ హ్యావ్ కంప్లీటెడ్ ద కాన్సెప్ట్ ఆఫ్ Lagrangian ఈక్వేషన్. నెక్స్ట్ వీ విల్ మూవ్ టు జాకోబియన్ ఈక్వేషన్స్ అండి. ఓకే, సో జాకోబియన్ రిలేటెడ్గా ప్రాబ్లమ్స్ సాల్వ్ చేద్దాం. ఓకే, థ్యాంక్ యూ.